All right, so in the last video, we went ahead and finished up the next set of the carbonyl reactions that we wanted to talk about there, and it's a very useful set of reactions. There's a lot we can do with all that carbonyl chemistry. But now I wanted to move into kind of maybe a quicker next section here. I want to talk about amines. Um, we've been using amines quite a bit as we went through the 2 semesters here, but we haven't talked too much about really how to make them too much. So let's go back and recap and review and just think a little bit about amines here and what we can do with them. So I guess the first thing is, what can we do with these amines? Or excuse me, let's talk about the properties first, I should say. So whenever you see an amine, you should, one of the first thing that you should think about is that they will act as a base. Like, very common use for amines is that they will be a base, triethylamine or pyridine, and ammonia even in some cases, right? These things will act as a base. We should know it also at this point is that they can act as a nucleophile, right? It's really hard to separate one from the other unless we use some kind of steric or electronic kind of control with that. So in general, amines can be basic and they can be nucleophilic, right? And so that's kind of that's all I really wanted to talk about in terms of just reminders with kind of the old things there. Something that we haven't really talked about much lately is the idea of chirality. Amines are chiral in a sense, and what I mean is this. So if we have Mr. Generic amine, okay, and let's say that generic amine has 3 unique things coming off of it. All right, and yeah, we can do yellow, that's fine. Remember, we've got this lone pair sitting over here, right? And so what can happen is we can actually invert, okay? So if we, I don't know, let's use blue, I guess. Yeah, blue seems good. What can happen is the nitrogen can actually flip, right? Wherein, right, we start to see an inversion of the around the nitrogen center. And if you remember back to your days of chirality, if I pick up the molecule on the right here, okay, I can't superimpose it onto the one onto the left, right? The black and the red isn't going to line up, or, one of the things isn't going to line up. So amines can be chiral in a sense, okay? So, who cares? It doesn't really matter, right? It's just something to think about. It's going to be important when you guys get into biochem, right? I'm not going to sit here and poke at you guys too much about chirality in the second semester, outside from the fact that we need to pay attention to, regio and stereoselective reactions, right? I'm not going to ask you guys, don't worry, right? It's not coming on the final exam. Or I'm going to ask you guys about, surprise, it's RNS, right? But you guys do need to remember that, and it's going to be important, and, when you take biochem. But just something to think about here, okay? All right, anyway, so that's kind of my very brief overview. I am not on this video going to cover naming. Naming's about as dry as you can get. You guys can look it up in the book. You guys can read it there. There's nothing I can really add in terms of naming with this stuff anyway, right? What I'm here to do for you guys, hopefully in this video, is just kind of digest some of the information from the book, but there's not much I can digest about naming, right? Naming is naming, and there it is. Okay, so let's review a bit about how we can make amines, okay? Now, perhaps one of the simplest ways to make amines, we could try to do something like this, where we just take a primary amine, we take something like ammonia, and we try and put it together in there, and the idea would be that we do an SN2 and we come out with this. And maybe on paper that would work, but in reality, right, what will probably happen is that we will end up, making a mixture of a bunch of different products, right? So on paper, it seems, oh yeah, just do an SN2 and we get this, but as soon as we make that amine, and depending on the ratio of stuff that we have in there, it's going to form the primary, the secondary, and the tertiary, maybe even the quaternary in some cases. So it's just going to end up making a giant mess. So it's really not the best way of doing these things. Since amines are nucleophilic, we have to be careful. We can't just think of what happens in one step and then, oh yeah, magically it stops, and that's the way science works. Well, we got to be careful with that, right? So let's think of a better way of doing this. If I take, or maybe not a better way, let's think of different ways of doing this maybe. So let's take that primary amine, throw in some sodium cyanide, okay? If we do this, well, let me change colors here, sorry. All right, perfect. So if I take sodium cyanide and, I don't know, I'd probably try to do this in acetone or something like that. It doesn't really matter, who cares? Okay, what we would end up doing, right, is adding that cyano group there. That would do a nice SN2, not too bad. If we come back and then we do a reduction with this, and we'll use everyone's favorite, LAH, right? We'll use a bunch of LAH, and every time we use LAH, we always need to come back and clean it up, do an acid workup, or in this case, we'll just do a water workup. Why is that? Okay, well, we'll come back and talk about that in just a second, okay? But we throw in some LAH and we throw in some water afterwards. What we'll end up doing is, right, let me do it like this. Okay. So LAH will reduce a cyano group, okay? Will reduce a cyano group. And that's a way that we can make an amine, and that's pretty nice, right? Don't forget, though, when we are adding a cyano group, we are adding a carbon also in there, right? So don't forget to count your carbons and do all that other kind of stuff. So if we needed to add a carbon and a nitrogen, this would be a fine way of doing it, and LAH is pretty easy. Why do we need to add water in there? Typically, we would do an acid workup. Why would we not want to do an acid workup? Well, you could, except that amines are bases. So if we wanted to do a acid workup instead, okay, if we did an acid workup instead, what we would end up making is not the amine, right, but the protonated amine. Oops, I forgot my plus, right? So we would typically just finish up with water. It works just fine, blah, 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 right? But reduction of a cyano group, fine. No way, nothing too unusual about this. Hopefully you guys can do the mechanism for all these cases, especially the reduction of the cyano group there with the LAH, right? Remember, a cyano group is basically, right, the way that we kind of talk about it is basically like a ketone. It's a carbon that's bound with pi bonds to an electronegative atom. So remember, the cyano group basically has a carbonyl carbon in there, right? This guy right here, that carbon that I'm dotting there in black, right? Remember, that's kind of the way that we approach that, okay? If anyone not from my class is watching this, I hope I'm not confusing you. Why would you guys be watching this anyway? Anyway, all right. I want to watch a random guy on YouTube talk about organic. Okay, so another way that we learned is if we can start from a carboxylic acid, okay, we can turn these into amines, although, all right, so 1, 2, 3, 4, 5, 6, there we go, okay. And this is you can see maybe how this would be a useful method of doing this also, right? Because now we can turn it into an amine. We don't have to add a carbon along the way like with the cyanos. And that might be useful, but we can't do this directly. We've got to do some intermediate shenanigans. The first thing we want to do is turn this into a more maybe manipulatable, easier to use, more synthetically useful functional group. I don't know. We want to turn this into an acyl halide. Okay. Can you guys remember how to do that? Right. And pause here for a second, think about it, look it up, whatever you want to do. 5, 4, 3, 2, 1. Okay, great, right? So some thionyl chloride, that's a good way of doing it. Then, right, if we throw in some ammonia, right, then we can make an amide. Okay? And then it's the same thing as last time. LAH and water, right? So LAH will reduce an amide to an amine. Okay, that's fine, right? A couple of limitations with this also, right? Carboxylic acids can only be terminal, right? They can only be at the end, which means you can only end up with, these kind of amines here, right? At the end of the chain, although, you can bring in, you don't have to bring in ammonia here, right? You could bring in something else. You could bring in a secondary amine, that would be fine too, right? But the point being, right, we have the limitation of having to start out with a carboxylic acid, okay? Cool. Let's see what else we can do here then. Ooh, right. This is something we did a lot, right? How can you guys turn maybe a benzene into an aniline? There's a couple different ways of doing it, right? We could go through the nitro, right? We could go through the nitro. And then do some kind of reduction, right? What do we want to do today? Maybe we'll just, we'll do a tin and HCl, right? That's fine. Tin or iron, or you can even do a hydrogenation or rainy nickel, and making a nitro and then turning it into the amine. That's not too bad to do, especially on aromatic systems. You could also go through another route wherein you do some, maybe add chlorine and then do some kind of amide and ammonia, right? To have some electrophilic aromatic substitution, right? That might work. Although again, that would work better if we have some more electron withdrawing groups on there. But chemistry on paper, we can take some different steps with this, right? So there's plenty of ways of doing this, right? We can either go through the nitro group, or we can, substitute out a halide for an ammonia if, we have compatible groups on there, right? So lots of ways of doing that. I'm not going to recap that too much because, we just finished up that chapter not too long ago, right? And there are videos that are online for that stuff. Cool. All right, so let's talk about something new, but something that's old then. So what number am I on? 4. Okay. So something we haven't used too much is azides. Now, azides are very useful functional groups synthetically. We see them used quite a bit in different places. But here is the structure of an azide, right? And obviously there's some kind of cation over here. I'll just do M+, right, for some kind of metal, right? Sodium or potassium or, lithium. Well, sodium and potassium are probably the most common ones. Anyway, who cares? All right. So we have this structure here. Now, what azide will do for us is it will be a decent nucleophile. Okay, it's a nice skinny linear nucleophile, so it'll be good at doing SN2s. And we will see it used in a couple different places. I think maybe we'll get to it. I don't know. Like I said, this timing this semester has been a little bit weird just with the transition there, but it doesn't matter. But anyway, I'm rambling here because apparently I don't have anyone else to ramble to at the moment. All right, so I got to ramble to a recording, and now I got to put online and look like a fool. Perfect. All right. There we go. We'll do some. We'll do a primary amine with some sodium azide. Okay. All right, there it is. Perfect. Okay. SN2 reaction, nothing too unusual about all this. Okay. Now if I come back in and I'm going to use a very rare reagent that we've never seen before, okay, so we'll bring in some lithium aluminum hydride again. So let's take a look at what happens here, although, this could be a good point to see if you guys can figure out how we could get our azide down into an amine, okay? So let me do this. I need to give myself some more room. Don't need the head of that arrow. Put that here. What we're going to end up doing is we'll end up here. Okay? So if you guys want to pause and if you guys want to take a look at this, obviously, sorry, I guess I should finish up. We're going to do a water workup at the end. I think that should be somewhat obvious at this point, right? That every time you have LAH, you have to have a water acid workup at the end. So see if you guys can figure out how to get to the mechanism here, right? You guys can figure it out. Take a look at this, right? We see positives, we see negatives, right? And I'll give you guys a hint. Another product that's formed along the way is our buddy N2 nitrogen, okay? So that should be maybe useful for you guys to try and figure out this mechanism. It would be especially, I know, listen now, I know I've been rambling a little bit, but focus in here for a second. One of the things that's lost when I record these videos and I just present them to you guys and I'm not looking over your shoulders in class and asking you guys to do this is, I say things like, all right, everyone try this, and then you guys are just like, oh, whatever, all right, this is playing in the background, and, you guys are just kind of off, listening to me, and that's fine. I appreciate you guys paying attention, but, really when I ask you guys to stop and try and do this, this is what I can do for you guys at the moment, right? This is an important reaction, and I would stop in class with you guys here and say, can you guys figure this out, right? This is a great test to see if you guys have been paying attention and what you guys have actually learned as we go through the semester, right? Or the year even here. Let's bring in some LAH, all right? Let's do the mechanism then. I'm just going to abbreviate LAH as a bunch of hydrides. That's a perfectly acceptable thing for me to do because I am not going to be all that picky about things, okay? So we do that. We hit that point right there. Let's just abbreviate the blue part as R because I don't want to draw that alkyl chain because I'm not going to say I'm lazy. I'm going to say I'm time efficient. That's a better way of saying it. Okay, so we brought in this, right? All right, we kick this up into a lone pair. That's neutral now, right? Now might be the tricky part here. Okay. So this is in black to this one here, which is in green. This has a negative charge, and we made this, right? And then we do the acid work up there, right? Or excuse me, the water workup. So not too bad, right? Not a difficult mechanism. Maybe this part will be tricky here to make the nitrogen, right? But N2, there's always a strong driving force to form N2 entropically and thermodynamically, right? You make a very strong nitrogen triple bond and you kick off a gas. Le Chatelier's principle comes into play, all these things, right? So every time we can kick off N2, that's a very, very useful thing for us to do. Plus, we don't have to worry about cleaning it up. Nitrogen just bubbles out of everything, right? That's got a very low solubility, in most solvents there, okay? But cool, so we can use azide to make an amine. Again, the limitation is we're trying to do an SN2 reaction. So, we kind of have to make sure that's set up properly. We do use LAH, right? That might be another limitation there, right? We have to use some LAH. Maybe I should circle that in green. And so remember, LAH is completely non-selective, right? It's going to go after everything. And so we can do a slight modification with this to maybe make it a little bit more useful for us. So if we have an azide, right, I'm just going to abbreviate it as N3, right? If we have an azide, we can also do the reduction with our good old buddy H2 and palladium or platinum. And that will simply leave us with our amine there, right? So a little bit milder conditions there than LAH. But remember, H2 over palladium or platinum is not that selective either, right? If we have any alkenes or alkynes in the molecule also, then those are going to get reduced along the way, right? We're not going to be too selective towards that azide there. Okay. Let's see, how long are we doing here? Ooh, about 20 minutes. Okay, so we'll come back with the next video. There's a couple more reactions to learn, but this has kind of been a good intro and kind of a good reminder of some of the things that we can do with amines. So I will see you guys in the next video.